Okay, so now that we have the artifact pretty much modeled and animated, let's start working on the core. So I'm just gonna finalize this with the traditional out null. And yeah, so let's go outside. Let's create another geometry container. Let's call this core dev. I tend to color development assets green, development nodes green. So let's actually turn on our clip here, going up. This may come in handy so you have an idea of the size of the things that we want. So for starters, we'll begin with the sphere. And the size of the sphere is going to be pretty small because it needs to fit inside. And I think this is a good size. Maybe even smaller, but for now, let's go with this one. So we're gonna pretty much be building this core with particles. This is gonna be a very basic particle setup, but it's a good introduction if you're not familiar with. And yeah, it gives you some really cool results. It's very fun to play with particles, and it's really easy to set up something in Houdini. To prove my point, I'm actually going to be creating a pop network and just connecting this to the first input. Let's check it out. Immediately we can see we have particles. Let's hide this for now. Remember, I kind of exaggerated the size of the points. So let me press D, go to geometry, and here, let's go back to the regular point size. So we do have particles being spawned on the surface of the object that's on the first input. Here, I'm gonna leave it as is, but here on the pop network, let's dive inside to see what's happening. So this is pretty much a DOP network, and as on pretty much every circumstance or every application of a DOP network, you need an object to contain the actual effect or the actual particles that you're going to be simulating on the top network. In this case, when you create a pop network, it pretty much creates you a DOP network with a pop object, a pop solver, and a pop source. That's pretty much it. It does a bunch of stuff for you. It assumes that you want to, if we go into the pop source, it assumes that you want to scatter onto surfaces. You do have other options, but this is what we want. You can disable the visualization of the source geometry if you want. Just go here and disable this. And right now, the birth is going to be controlled by not impulse activation, but constant activation. And the constant birth is 5,000. So this means that let's check out here. So we have 5,000. At this point, after 24 frames, we should have 5,000 particles. So pretty close, 5,000. So that's pretty much what it means. It means that we'll be emitting particles at a rate of 5,000 particles per every 24 frames. The reason why we don't see anything happening is because the particles are just being born on that surface and nothing else is, we're not determining anything on their attributes or on the forces they're subject to in order for them to actually be able to show some dynamic motion. But this is good enough for us to have an idea of what a particle is. So a particle is pretty much just a point with a bunch of attributes. If you middle mouse button here, you'll see we have age, we have an integer attribute to see if particle is dead or not, position previous, ID, life, a bunch of them. The most relevant ones will be usually the age, the ID, life, velocity, and that's pretty much the most important ones that we're going to be playing with. Of course, you can apply color, you can apply whatever you want to them, and they will inherit whatever attribute the surface has. That's something that you can do. So at this point, the goal is for us to kind of start controlling how they are generated instead of just generating random particles in a random position on the surface all over in a very uniform way. The other thing we want to make sure is that we have some initial velocity on our particles, and that's going to be coming from the surface as well. Okay, so let's start playing with the source. Our sphere currently is just a primitive that doesn't allow us to do much, so let's switch this to polygon and let's increase the frequency so we do have a bunch of points to play with. Let's actually go up to 16. So now we have a lot more, a higher density of points. The first attribute we're going to be playing with is the density, and we're going to be using density to control where the particles are being spawned. So let's create an attribute noise. Let's call this density. Let's call this, it's a float. And let's have a look at it. Just press this little lamp here. Let's make sure it's animated, and let's make sure the scale, the element size, actually fits the size of the sphere. So our sphere is at 0.05. So here it would make sense for us to go at least 0.04, something like that. We're not seeing anything, so not here. So here is one, element size 0.04. Sorry about that. Okay, so now we have some animation. Let's play it. Make sure you have real time on. Okay, so some nice animation. I don't really like this type of visualization for things that go from 0 to 1. So I'm gonna right click here, pencil, and just change the color, white to red. So white is 0, red is 1. Okay, looks good. Nothing too fancy. Just want to play with kind of remap this to increase the contrast in a more controllable. To me, it's the easiest way to actually control this type of thing. So I kind of remap it. So just put in the name of the attribute you want to remap, and then you can just play with this. The input range and the output range is exactly 0 to 1, so that's fine. But I want something more like this, where we have some gaps going on. Maybe even bigger gaps. Yeah, I think this is cool. Okay, so now that we have density, let's see if we can make use of this. So I'll leave this remap density, just in case we have another remap. Now you go inside and let's disable the visualization. By default, if you go to the attributes, inherit all attributes is with a star, which means our particles will actually inherit all the attributes coming from the surface. Okay. But here on the source, what I want is emission attribute. I'm going to go with density, not density, density. And then you have this. And you can see that now we have particles being spawned based on the density attribute. Okay, they're not being spawned all over. Okay, so we now have a bit of a texture to it. What else? If you want to increase the density of the points, you can also scale point count by area, or you can just go to the birth and increase this. So let's go to 50,000. Okay, sounds good. Now, the next thing we want to do is have them moving. So let's make sure we have some movement on our particles, because right now it's kind of really not very interesting. The way I'm going to do that is I'm going to create some normals, play with the normals, and then convert those normals into velocity. And that will be inherited by the particles, and velocity is an attribute that will actually affect the simulation. So the particles will inherit velocity, which means that on the next frame, based on each particle velocity, the position of that particle is going to be calculated based on that. So the first thing I'm going to do is start with some normals on the points. We can have a look at them. They'll be pretty big because this is a kind of a small sphere. And after that, I'm gonna use again an attribute noise. Let's start noise, attribute noise. And here, this time we actually want vector, but it's called normal. And what we want to do is pretty much add. The range values shouldn't be positive. We kind of want to affect the vectors on all directions, so we should have it 0 centered. And again, the element size needs to be fairly small. Now we also want some animation on this, and let's play. So you can see that now we have some variation. Overall, the main direction of the particles will always be kind of eccentric, so from the center of the sphere, from the surface of the sphere outward, but plus some kind of small distortion applied by this attribute noise. It's no longer by default, or traditionally you will want your normals to be normalized, but in this case it doesn't matter if it's not normalized. We're actually going to be converting this into velocity, so that's totally fine. I'm gonna just create a point triangle for that purpose, and it's pretty much a simple expression where we're just going to be saying that the vector attribute velocity is going to be equal to the vector attribute normals. That's it. Now we have velocity in our particles. Let's convert n to v. Attribute noise normals. So we have two sections. We have density and then normals to velocity. Let's have a look. Let's make sure we don't have. And you can see already. There they go. Particles all over. If you remember, one of the attributes that I mentioned, or two of the attributes that I mentioned, were age and life. So let's have a look into that. So here on the source, birth, this is where you set up your life expectancy and life variance. At each frame, each particle's age will be incremented, or at each substep, each particle age will be incremented. If the age goes over the life expectancy, then it is considered to be dead, and it's automatically removed from the simulation. So let's go with something like 0. Nope. Let's go with 0.8, 0.4 life variance. So we will have particles age with particles with a life expectancy that goes from 0.4 to 1.2. Now let's try this again. And if we zoom out, we should be able to see that now they don't go on forever. They kind of die out a bit. Okay. Let's switch the display to actually here on the geometry. You do have an option to display particles as pixels. And when you have a lot of particles, it actually makes it a lot easier to visualize what's happening. Cool. So this is kind of a good start, I guess. So we have some texture on the emission. We have some variation on the velocity as well, which adds another bit of texture to that. And yeah, and we're setting up some limits to the how long the particles should live.